Welcome to another Isabellenhütte product info program about analog current sensing in battery management systems. Isabellenhütte is a global company delivering innovation in alloys, precision and power resistors, and precision measurement through the efforts of more than 1,100 employees from Germany to Japan, China to North America. Our tradition of metallurgical excellence starts with a 500-year history of creating unique alloys and includes pioneering the future of precision measurement and power resistors alongside our customers. Every day, we work with the top names in automotive, aerospace, medical, and other industrial sectors where we serve as a responsive and active partner in next-generation solutions. Our popular products are based on proprietary alloys and a centuries-long reputation in engineering and supply chain excellence. The purpose of this brief video is to provide engineers and product designers with an overview of the many options available from Isabellenhütte and to highlight some of the unique features of our one-of-a-kind current sensing solutions used in battery management systems and other applications. The major functions of a battery management system may be characterized as current shunt monitoring and busbar temperature measurement. Several BMS functions can be performed using analog sensors, including decentralized interlock, cell supervising electronics, high voltage monitoring, thermal event detection, current-triggered short-circuit interruption, and isolation measurement, among others. With the help of analog current sensors, readings are made available as an analog signal via a circuit board with a connector soldered onto the busbar shunt. Sensors may be connected by various methods, including terminal position assurance, independent secondary lock, or connector position assurance. Per Ohm's law, the current sensing module's voltage signal is provided using the voltage drop compared to a known resistance value in order to calculate the flowing current of the battery pack. As the resistance value of the shunt changes due to temperature fluctuations, the busbar temperature of the hotspot is also determined via an NTC and sent to the interface. The NTCs on the PCB are very temperature sensitive and react quickly during operation. Calculation algorithms can be used to perform temperature compensation of the temperature-dependent R value using the NTC signal. For redundancy purposes and to ensure the required functional safety of the overall system, at least 2 analog voltage signals and 2 analog temperature signals are made available to the customer in HV systems. Additional voltage or temperature signals can be provided on request to support, for example, a quick plausibility check. Fewer voltage and temperature signals can also be provided if required. The analog signals are transferred from the sensor to the analog front end of the main BMS via interface and pre-assembled cables. When measuring current using shunts, the high voltage side of the shunt and the low voltage side of the BMS must be isolated at the analog front end, indicated by the insulation barrier here. The advantage of analog sensors is that you don't have to connect the PCB of the main BMS directly to the shunt if it is not centrally located or if the system architecture does not allow. Not to mention, it can sometimes be difficult to solder busbar shunts onto a smaller PCB. Analog signals are used to determine the state of charge, state of health, and state of power parameters. SOC monitors the charging process of the battery, SOH reports on the battery's state of health, and SOP is used to monitor the maximum current the battery can deliver or absorb in a specific window. This use of analog current sensors supports the gentle charging and discharging of the batteries, increases the service life, and protects the batteries from prolonged high currents that could destroy the battery. Our analog current sensors are found in 12, 24, 48 volt, and high voltage battery-powered automotive applications such as trucks, buses, motorcycles, and cars. Further applications include use in stationary and mobile high-voltage energy storage systems. Additional applications for our analog current sensors are being explored, including implementing them in the phase current measurement of inverters to provide analog values for PWM modulation. While Hall sensors are currently used here, the use of analog current sensors can improve the efficiency of a drive system. In addition to analog signals, Isabellenhütte provides further product-specific information via a DMC code lasered onto the shunt. An individual serial number is assigned to each component, which enables complex traceability, including the melt of the alloy and the measured resistance value of the end-of-line system. Other information can be applied to the DMC code, including the individual polynomial curve of the temperature coefficient for each component or the values of its NTCs. It should be noted the temperature coefficient is determined with high precision for each shunt individually and not for a production batch. This is an exclusive feature of Isabellenhütte sensors. Reading these values enables the data to be transferred to the battery management system and provides a simple plug-and-play solution. Our analog sensors provide the perfect interface between your standalone shunt and an active current sensor. The nomenclature of our sensors is relatively simple. The first two letters stand for the words battery sensor, and the third letter indicates the shunt's basic design. So a sensor based on the BAS shunt, a common example, would be called BSS. The following digits show the resistance value in microohms, and the L highlights the low ohmic nature of our products. The last three digits indicate the product version number, typically indicating different PCB configurations as well as different shunt dimensions such as hole spacing, hole diameter, or a special coating of the shunt. Beyond our off-the-shelf sensors, our engineering and alloys teams are available to work with you in the development of customized sensors. Direct coordination with the experts at Isabellenhütte is particularly useful for special automotive applications and other complex products. With many years of expertise in the field of shunt-based current measurement, long-term stability simulations or other tests can be carried out on request. In addition, we are continually innovating our analog sensors based on customer feedback and market demand. Some current planned projects include sensors for lower resistance values of 20 and 25 microohms, aimed at helping customers achieve ASIL-D classification at the system level, and more size options to help in space-constrained applications, packaging requirements, or other shunt geometries that are also possible upon request. If you are constrained by a list of approved connector manufacturers, for example, Isabellenhütte has the capability to implement PCBs according to customer requirements. Our expertise in the design of NTC areas or PCB layout in the direction of the shunt allows you to count on optimum temperature detection. The benefits of incorporating current and temperature sensing data into your battery management system are clear. Easy integration into your BMS. There are a wide range of resistance values readily available. Many applications can be addressed, and these sensors fill the gap between standalone shunts and CSM solutions. Isabellenhütte has the proven expertise to help you identify or create the ideal sensor to suit your particular application. In addition to this video tutorial, more product details may be found on Isabellenhütte's website. Featured here, you'll find our Product Finder, which allows you to very quickly find suitable Isabellenhütte components and products using a variety of criteria, including part numbers from other manufacturers. Thank you for watching.